2022 deferred question 9, part C. The surveyors know that the horizontal distance between the mountains G and P is 8.3 kilometers. They measure the angle of elevation of G from P, marked theta in the diagram below, not to scale, so you can't measure it. They use this to find out the vertical distance h. For their calculations, the surveyors round the value of theta to the nearest degree, giving 6 degrees. Okay, so when they're doing their calculations, they're using theta to be 6 degrees. Now, straight away, I can see this is a right angle triangle. So things like Pythagoras and trigonometric ratios are coming to mind. So let's read the question. Use theta is equal to 6 degrees to work out the surveyor's estimate for the value of h. Give your answer in meters, correct to the nearest meter. So I can't use Pythagoras because I only have one side, so I need to use my ratios. If I'm standing at the 6 degrees, h is opposite me, 8.3 is adjacent, so I need to use the tan. So the tan of any angle is O over A, opposite over adjacent. The tan of 6 degrees in this case is opposite, which is h, over adjacent, which is 8.3. So I'll pop that over 1, cross multiply. 8.3 tan of 6 degrees is equal to h. So I have 8.3 times the tan of 6 degrees. Now that's coming out to be 0.8723, etc. for h. Now it says, give your answer in meters, correct to the nearest meter. Because the question's in kilometers, that's actually in kilometers. So if I multiply by 100, I get 872.3 meters. And to the nearest meter, that is 872 meters. So I know that h is 872 meters. Find the maximum percentage error in the surveyor's estimate of the height h. Give your answer as a percentage, correct to 1 decimal place. Remember that the surveyors round the value of theta to the nearest degree. Okay, so what they're basically asking here is, given the fact that the surveyors did rounding, there is going to be this percentage error. Now, you haven't really done percentage error in the course so far, but you probably would have come across it in, well, you would have come across it in the junior cycle. Whether you remember it or not is another thing. So the idea here is, I guess, if they considered the angle 6 degrees, there is a possibility, and the smallest possibility is the angle was actually 5.5 degrees. Because if an angle is 5.5 degrees and I correct it to the nearest degree, it gives me 6. But there is a possibility that you're at the maximum end of the spectrum. What if it was 6.4 degrees? That would have also meant that I would have rounded it back to 6. So there are those two options basically. So if I redo the question using those values instead of the 6 itself, then I should be able to see the difference in the calculations. So we're going to do, so ultimately it's going to be the tan of 5.5 is equal to h over 8.3. So I'm going to multiply 8.3 by the tan of 5.5. So 8.3 by the tan of 5.5, and that's giving me 0.7991. Now that's in kilometers, so 799 meters. Now remember, above it was 872, so there certainly is a difference. But before we talk about that, let's do the same for the other end of the spectrum. Let's use the 6.4. So if I use 6.4, that gives me h over 8.3. So I do exactly the same thing. 8.3 tan of 6.4 is equal to h. So 8.3 multiplied by the tan of 6.4. And that is 0.93099 is my h. So that's what, 931, I guess, meters if I round to the nearest meter. So we have the kind of two ends of the spectrum here. We have, I suppose, the largest the H could be and the smallest the H could be, and then the somewhere in the middle, I guess. So when we're doing the percentage error, we want to look at the difference between the estimate and what we have, you know, and we want to see, well, which one is more away. So is the 5.5 degrees further away than the estimate, or is it the 6.4? So which one is the maximum percentage error? So I guess what we're going to do is we're going to do our 872 minus 799 all over 799. So in other words, we're looking for the difference between the rounded version and the actual, and we're dividing by the actual, what we imagine to be the actual anyway. So that gives us 9 point as a percentage, 9 point, sorry, I never said multiply by 100 because we're doing percentage, multiply by 100. So that gives us 9.13%. Now it says percentage to 1 decimal place, so actually 9.1 will do there. Now we'll do the same on the other side. So 931 minus 872 all over 931. And again, we'll multiply by 100 because we want to get it as a percentage. So we're looking for the difference between the value and the rounded answer that we had from earlier, and changing it to a percentage by multiplying by 100. 931, so what's that? That is 6.33%, or 6.3 really. Now it's asked us, what's the actual question? Find the maximum percentage error. So the maximum error is the 9.1. So that is, I suppose, you know, how far out it could be. So the 9.1% appears to be the furthest out the sum could have been. So 9.1.